Hello, so welcome back. Sorry for missing this channel for quite many days. So now I'm back with the same topic that we're going to study is the open channel flow. So open channel flow, as you can remember, it is all about the flow with free gravity. So free gravity alone. Yeah. So when there's water, it flows with free gravity alone. It is open channel flow. So this is one of an example. It is a prismatic channel with a symmetric cross section shown. So there must be a picture. So I'm going to draw a picture for you guys to see what does the channel looks like. So this is a rectangle like this first, and then we have this one. It's like this. So let's imagine. We were not assuming because that is given in the question. So we are imagining that this angle is perfectly 30 degrees, which is, it is not. Yeah. How do I draw this perfect diagram? So this is 30 degree and the height here is 0.8. 0.8 meter, 0.8 meter. So basically, they gave us the rate, the Q is 1.5 cubic meter per second, and the Manning's N is 0.02, which is, I don't know what type of material is it, because I only know the concrete is 0.013. And for string-wise slope is 0.1%, which is 0.001. Am I right? 0.1 divided by 100 is 0.001 is right, 10 to the minus 3. And then we can find the normal depth that is related to the lowest point. So the lowest point is basically the bottom of the channel. So now, without any further ado, let's start our solution. So I am trying to write it so neat this time. So see my what do we say, that evolution. So we can find the okay, so now let's consider this one. We can see that the angle is 0.3, which makes the surface width here equals to 2 times 0.8 root 3. Yeah, because this is 0.8, right? So we're finding this one. So this one's supposed to be 2 times, because we have here and here. So this is only this part. So we're going to 2 times. So now we have 2 times with 0.8, and then we have root 3 here. So let us take a guess. We're going to use cos, right? Cos 30. Wait, let me change my calculator to degree. Yep, okay. Cos 30 degree times 2. Okay, so here we have 2 times with 0.8 times with cos 30 degree, 0.8 cos 30 Is it right in degree? Yep. 1.3. Wait. Are we using tangent? We're finding this one, right? So this one, yeah, sorry. So we're using tangent. Interesting. Yep. We're not using any cosine sign. We're using tangent. 30 degree equals to 0.923 meter. And for the sloping side, so for you who wonder what is a sloping side, so basically the sloping side is this part here. It's a sloping side like this. So the sloping side here comes from the hypotenuse and this one. So we have this one is the opposite. So sine, we're going to use sine. So basically sine 30 times 0.8. Am I right? Oh my gosh. We have this one, right? 0.8 sine 30, is it? Why do I get different answer from the answer sheet? Did I forget something again? Or are we using chaos this time? Okay, so I don't want to waste our time. Let's say I believe the answer sheet here. So the sloping side here, it says 1.6. Oh, it says 1.6 meter. Please give me some seconds to think of it. So the sloping side, of course, it's the hypotenuse, and it's the h, and this is the opposite of this angle. So sine 30 equals to 0.8 over h here. So we're finding this one. Oh, 0.8 divided by sine 30. Nice. Yep. Well, I have all my trigonometry done. So 0.8 divided by sine 30 equals to 1.6 meter. And then we can find the R, A and R. So R comes from A and P, right? So first, let's start with area. Area start 1 over 2 times 0.8, which is the height, and times the width, or we call it the base. So it's 1 over 2 times 0.8 times 16 root 3. It's 1.109 meters square. And then we can find the perimeter, the wetted perimeter. So it's 2 times 1.6, which is basically 3.2 meter without any calculation needed. So now we can find the RH. RH is A over P, which is 0.0109 meters square over 3.2 meter equals to 0.3466 meter, because this is square and this is no square. So then we can find a V. So the velocity. Okay, so velocity U is equals to 1 over N RH 2 over 3 square root of S. So as it is mentioned earlier, it's 0.02, right? Yeah, it is 0.02. So 0.02 is the N here. 0.02 times with the hydraulic radius. I almost forgot what RH is. So that's the result of not reviewing the lessons during the the holiday, the weekend, and I'm doing now, so that's why. Sorry, guys. So this is M here. I think the Manning equation, the Manning S has M. Interesting. We need to put all the what do we call that one? All the units. 2 over 3 times square root of 0.001. So now let's calculate this together with the calculator. We have the velocity. Okay, so now we have the velocity. We can get 0.7802 meter per second. So now we're finding the q, which is q equals to UA, our velocity in the area. And then we have 0.2802 times 1.109. And then we have the final answer. No, not the final answer, because the answer is asking for... What is the answer asking for? The answer is asking for the normal depth here. So it says, it gives us the Q. And why are we finding the Q here? The reason is that it is less than the required depth, the required flow rate. So we have to change something. And yeah, we just, so we have to, if the depth is above and below the V, I mean the V here, so if it's above or below this V, if 1.5, okay, so if this one, we found the number here is less than 1.5, which means that 1.5 is somewhere around here, so it's above the V. But if they give us 0.7, for example, so it's somewhere around here, so it's below the V. So we need to precisely equal to the top of the V, 0.8. So therefore, you need to tell the normal depth and the critical depth. It lies below or above this V line here. So now let's proceed to the next part of solving this equation. We for the fruit number. Sorry if this is wrong. The fruit number. I feel weird whenever I say this word. So the fruit number. I'll say it at the same time. Fruit number. U equals to Q over A. So Q here is from the exercise, meter cubed over second over 1.109 meter square. And the answer is 1.5. 1.353 meter per second. So this is not a normal flow. This is just the flow that is from the exercise, that is from the problem. And then we can find the H here, which is something above here, H bar. A equals to BS, and the answer is 0.64 with 3 over 6, 1.6 root 3 equals to 0.4. So where's the number from? This is from 0.8 square. I'll just write it in the highlighter. So 0.8 square times 10 gen of 30 over 202 0.8 squared times tangent of 30 over 2 times 0.8 tangent of 30. So this is from, yeah, the BS, the base, right? It's not the base. So we have this one, and this is 30 here. And tangent 30 is OA, opposite here, 0.8 here, over this one. Ah, okay, got it. Okay. So now we have the fruit number that is equals to V over 2, oh not 2, square root of GH. But because we have 2H here, so I don't want to confuse you guys, so let's just put another thing, H bar or H prime or H something. So oh, this is U because of velocity. You guys can use V or U, but I prefer U, so you guys can write V or something else, so that's the same. V, the bigger V, the smaller V, as long as it's not the same as the viscosity symbol. So 3 meter per second. So as usual, it's 9.8 times 0.4 meter. So the answer for the fruit number is 683. Now this one doesn't have any what do we call that, any unit, because this is m, and m squared over s times m, so no, m over s squared times s m, so this and this becomes m squared over s squared and square root, so this and this is gone. Okay, so now we can see that the critical depth here is below the top of the V. So we can see that this is, oh shit, oh sorry, I did not swear, I was like, see, yeah, oh see, this is below than, this is less than 0.8 meter, which is below this V, and 0.86, and this is less than the required one. So the critical depth here is below the top of V, So we can conclude later, A here, which is basically the area, 1.109 plus h minus 0.8, which is the height of the V, height of the triangle, and then we times with 1.6 square root of 3, and it equals to, okay, so this one, and everything, oh wait, this one, and everything here, this one, and this one. So this is the result there, 7.771H minus 1.108. Okay, and then we can see that P here equals to 3.2 plus 2. 3.2 is from the previous one, it's 2 times 1.6. And then we can find the following thing here. 2h minus 0. This one equals to 1.6 plus 2h, not 2 hours, it's 2h, 2 height. Okay, so we all know that Q, I need to add another, why is not the same? It is A5. Okay, so Q equals to AU, stands for gold, and s square root of s over n and times a 5 over 3 over p 2 over 3. So this is equal to why am I so chill right now? 0.01. I don't like this. 0.1. I'm sorry for my neighbors who are trying to slam the doors. I also don't like it, but I have no choice. 0.02. As long as they don't hear me complaining, so that's fine. A here is 2.771. I'll say x because we're going to use the solver in the calculator anyway, so the solver in calculator will eventually have it as that one. Okay, so then we have p here is 5 over 3 and p here is 1.6 plus 2h 2 over 3 and q is equal to something. Q is equal to 1.5. This is what we're aiming for. 1.5 alpha cal equal to square root of 0.001 over 0.02 times bracket 2.771 alpha x minus 1.108 power 5 over 3 over down here is 1.9 or 1.6 plus 2h over 2, 3. We solve for it and we find that the numerator that we have here is 0.69. Wait. I got a different answer again. I'll just compensate you guys and I will meet you guys real time face to face and try to solve all of these. Oh my god, what's wrong here? I'll go for another time. This is also a new time for me to use the solver. I haven't been using solver for I have never been touching the solver equation, you know what it means, right? Times. I have never touched any kinds of solver in the past. This is my first hands-on experience in using this solver problem, and it basically painful because I don't really know how it works. 0. I wish I could just show what's on my calculator right now. I feel like I'm talking. Like the calculator is a lot of number here, but you cannot show it in this screen. How can I share the screen from the calculator to the iPad? 5 over 3 here. Okay, and down here is 1.6 plus 2 alpha x and everything here power 2 over 3. So I got the same number again. I don't want to use the solver anymore. Do I have to times or something 1 over 5 over 1.581 0. Okay, so I tried doing this over 1.581 times something, right? So this is equal to 0.9487. Alpha equal to, this is my last time attempt to do this one, 2.771 alpha x minus 1.108, everything here, 5 over 3. I'm using everything as the same thing here, 2x I get the same number. So I'm not gonna copy from my calculator, I'm gonna copy from the answer sheet. I will find the answer, the right answer, why it's not right. So x here equal to 0.981 meter. So when we come to question B, when h equals to 0.981 meter, the a here equals 2.771 times h minus 1.108, right? So it becomes 0 like this times 0.981 minus 1.108 equals to 1.610 meters squared like this. And then v equals to q over a here. And then we have 1.5 over the actual flow cross-sectional. So now we have 0.317 meter per second. And then we can find the BS. BS here is equals to 1.6 times square root 3 equals to something equal to something times square root of 3, it's 2.771, and then we find the h bar here equals to a over bs equals to 1.610 over 2.711, and the overall here is equal to 0.581 here meter. And then we have the foot number equals to u over square root gh equals to 0.9317 over everything, that is 9.81 times 0.581 equal to 0.3903. And this is the period number in normal flow. And then lastly we can find C, which is the critical flow. So in this critical flow we have how are we going to survive this critical flow? Critical depth. Just kidding. I meant to delete this one. Why did I highlight it? Okay, so now we have the critical depth is defined if the fluid number equal to 1, right? So if the root number equals to 1, so fruit. So what if root square, it will be equal to q over, because this one is q over a, right? So q square times bs here equals to g times a to the power of 3a cubed. So then we can find a equals to 1 over 2h times 2h square root of 3, and then we find root 8 squared. So after that, we are going to substitute all the numbers in the Froude square here, and then we get 1.5 squared times 2 square root of 3h, and this one, everything here, 9.81 times 3 root 3 of h, 6 to the power of 6, and then we find 0.1529 over h5, and then we can find h5 here equals to square time 0.1529. So when the Froude square equals to 1, h to the power of 5 equals to 0.129. Root of the power of 5, it equals to 0.68. Really? 진짜? 5, 0.1529. Yep. Meter. So the critical depth here is, okay, so now we have the critical depth here, the normal depth here, hn, and the, what were they finding? Fruit number at normal depth. hn, where's hn? Okay, and hn normal depth here, 0.981. So these trays are the number. Okay, so basically it's the only thing that we are stuck here is how did we find x here? Should I try solving the equation this way? 1.5 equals to 1.5 equals to 1 point. Well, this, oh, it can be like this. Yeah, it's not square here. Did I make a mistake here? I really want to solve this one for real, but I cannot do it. Equals to 1.581 times, okay, I will use double bracket in order to avoid any confusion for my calculator, for my lovely calculator. So yep. Another bracket here, and then sign here, and then minus 1.108, and then another bracket here. Oh, nice. Everything is ruined now. 1.5. Okay, this will be the last try ever. So if this is still a failed try, I'll leave now. 2.771 times alpha x Okay. Minus 1.108. Everything here is 5/3. And down here, like, I wish I could show you this. I feel like I am fighting alone with my calculator. 2/3. 3, right? I'm doing the right thing here. So, shift, solve. I get the same number again. I will try to figure out how did they do that. So, yes. So this is the answer. For the next one, I guess I'm going to skip this exercise because we're going to use some solver again, and I don't want to see the solver here. So I want to. Okay. So now let's just stop here, and the next time I will show. I will basically do everything in. I might show in the Excel or not in Excel, so stay tuned. I'm sorry for this clip. I think you guys don't learn anything from this clip, but yes. We can practice finding the P, the A, and the Manning equation for it. So thank you so much.